All right, let's take a look at this one. What is the antiderivative of 1 over x? This one you got to be careful on. If you kind of try doing it the way we've just done a couple of these other ones, and think of this as x to the first and move it up to the numerator, that would be x to the negative 1. So if we try finding the antiderivative here, we would add 1 to that. However, if you add 1 to that, that's x to the 0 power, and we know we have to put the reciprocal in front, which would be 1 over 0. Can we have 1 over 0? That's trouble. This is one that you just kind of got to remember, and I bet if you think about it, you can probably figure out what this antiderivative is, because what derivative did we have from before? That if we took the derivative, the answer came out to be 1 over x. Well, if you remember, that's natural log. And so the antiderivative of this is natural log of x plus some possible constant. And when doing these ones, we actually, when doing antiderivative, it comes out that it's absolute, natural log of the absolute value of x plus some possible constant. And we put that absolute value sign on there because we could put negative numbers in here, like we can do like 1 over negative 2. But if we didn't have the absolute value sign here when we did antiderivative, can you do natural log of negative 2? No, remember, you can't do natural logs of negatives. So we put the absolute value sign so you can still evaluate that at values. So whenever you're doing antiderivative of 1 over x, you just got to remember, oh yeah, that one's natural log of the absolute value of x. Okay, another one you should know, this one's super easy. What's absolute, or what's antiderivative of e to the x? Well, derivative of e to the x is e to the x. So that means antiderivative, same thing, is e to the x, plus a possible constant. Trig ones, same thing. We know these trig derivatives, so now we just got to think backwards. So what is the antiderivative of sine x? Well, to get this one, think back to our derivatives. Derivative of sine x is cosine x. And we also know derivative of cosine is negative sine. So what does this one have to be so that we end up with positive sine here? Well, we know it would have to involve cosine of x. So, and we know we got to have a plus a possible constant on here. So would that be correct? Well, if you want to check it, find the derivative of this. What's the derivative of cosine x plus c? Well, derivative of constant 0. Derivative of cosine, we know from over here, is going to be negative sine. Is this matching up with what we have up here? No, we don't have a negative in this problem. So what do we have to do on our antiderivative then? It would be negative cosine x plus c. Now if we find the derivative of this, we got that negative, derivative of cosine is negative sine, derivative of constant 0, so what does this end up equaling? Positive sine now, just like we started with. So whenever you're doing these antiderivatives, just make sure if you would take the derivative of it, you should end up back where you started. Some other antiderivatives then that you should know, if we do any combination of functions by adding or subtracting, it's just the antiderivative of each one of these two. If there's a constant in front of it, we just bring that constant with. We have our power rule we talked about. Antiderivative of 1 over x is natural log of the absolute value of x. E to the x we talked about. Antiderivative of cosine would be sine because derivative of sine is cosine. Antiderivative of sine would be negative cosine. We just looked at that one. Remember our other trig derivatives. What's the derivative of tangent? Secant squared. So what's the antiderivative of secant squared? Tangent. What's the derivative of secant? Secant tangent. So then the antiderivative would be secant. And then we'll get into some of these inverse trig ones as well later on, but remember that We found some of these antiderivatives inverse by using implicit differentiation and drawing out a triangle. So if you would see something like this and it says find antiderivative, it would be inverse sine, just like this one would be inverse tangent. We'll keep working with those as we go here.